So they flow a cell with a bigger diameter than the end diameter in it. It gets stuck, and then they increase the pressure to get the elastic response of the cells.
And are you talking about biological cells, really?
Yeah,
Human?
Yeah, human cells.
It's human?
Yeah.
Amazing.
And they're not doing it by hand, so they have a pump.
No, it's impossible. I mean...
Increase the pressure till one gets around the point, then they shut off the pump manually. And then there's the steps, and they want me to automate it. So I have to make a computer that sees the position of the cells.
At the
And
end?
the pumps, and then turn off the pumps at the correct position.
Man, that is so cool. And what about the pump? It's high precision pump, a motor.
No, it's with the height.
Ah, the gravity. You're using the gravity.
They increase the height, and then there's more pressure.
And what is... I am asking you this because the control, and we are going to do that in this project. What are the controllable variables? What are the controllable variables, and what are the state variables? Do you know what I mean?
Yeah.
Controls?
Global variables, it's completely up to me. If I want to put 5 pumps in it.
No. My question is, variables are the formulas. Go to the formulas. You are very good in that.
Yeah.
And go to the formulas and the physics and the whole model, taking into account all the little things, the high thing, and the sensitive, high sensitive, low sensitive, and focusing all the variables. You know, the list of variables.
Yeah, I basically only have the pump variable. There's just a flow going in with all the cells, and then the pump is pressure or a high difference.
Okay.
That's causing the flow.
Let's go. Yeah, I think I can help. Not help you, just discussing. That you have a state variables. You have it here indirectly. The pressure, the gravity, mgh, gravity, field energy. So you have state variables, and only this is the controllable variable. So you can, in the control system, it's the important thing you are doing. Control variables and state variables. So you have only one here. Wow, that is not so cool, man. And then here is gravity, mass, the G also, the height, and another thing, like the diameter and the position of this. Do you sense the position?
I'm trying to. I have to figure out if it's possible. But
yeah? Well, you should do it.
Yeah.
Like
it's either the position of the or the flow.
Okay, good.
If
I
you
like
sense the flow, it's
flow and these are the things you can put in the control system, but you cannot put this because these, even when are variables, these are constant.
Yeah.
Constant. You cannot affect it, and the variation of this and really changes. You cannot do something. Let's call this energy of the gravity or whatever. So I think you can do it, man. Later you will discover that you have to know this data. You already know this, correct? I mean, you can measure it.
Yeah.
Okay. Well,
but I can also measure the position of it. If I put a sensor in front of the opening of the end, it can sense.
You should do it because you have this. You have the system which you can touch, you can change and sense these variables. So if you have 2 variables, that is nice. But if you have only one, man, it's really difficult to do a good project, a good system.
Yeah, but you need the distance.
Yeah.
It's dependent on the diameter of the cell, which I don't know, which you can control.
But you can estimate. I mean, this is not.
They're all different.
Yeah, I know, but there is a range. That's what I mean. There is a range.
Yeah.
That's what I mean. A minimum and maximum.
The drawing is pretty big.
The what?
Your cells.
Yeah, I know. Different tissues, different diameter. But I think you can do it. I mean, you can put a table, exactly. You can put a table and build up the data. And the table is the D distance for several, for human, tissue of the liver, tissue of the whatever, bladder. So you have minimum and maximum. And because you have the minimum and maximum, it's more easy to do the control. Minimum and maximum. You can put it in the system. So you have D small, you have F. And what is your goal? What is the goal?
The system needs to capture of the cell, so get it stuck by itself.
Yes.
And then needs to be able to flow it out. So increase the pressure that much that the cell deforms and shoots out of the end. And capture a new one. In between, it needs to take pictures of the cells and increase the pressure in steps to see how this cells deform.
Okay, so a camera here, and camera here looking. And
Camera on the top and bottom.
Okay. So the goal is just to observe it. Yeah. And measure something. I don't think what.
The deformation of the cells, the electric response.
Okay, so you
can measure the volume change and the how it deforms. And with that you can calculate.
Can you measure deformations of a sphere in some way with electronics, sensors,
no.
Camera?
They take a picture and just look at it manually.
Take a picture?
They take a picture, yeah.
Uh-huh.
Just look at it.
Sorry.
Manually.
Shit, man, it's really manual. I mean, it's really, really manual.
Yeah.
Okay. Okay, and this is constant also. Let's call it DO from the opening. Oh, well, I think it can be done better with, how do you know, neural networks, you know? But you will have to do it many, many, many times, many samples, and build up the data. Well, you will do it anyway. When you start operating, you are doing that.
It's not my project to do the data analysis. I just need to build a system that controls the pumps. And,
okay. No, I know what you mean. Your goal, the goal. But this tool is needed for doing this fully automatic. Yeah. And that's what you want, and what the university and the client is expecting from you.
I just got this subject. This is my project. I know I can do a lot more. I can redesign the whole system, but it's not my project.
I know you can.
Keep on this, and they need to manually analyze the data.
Seeing many pictures. Yeah. Well, you can do even more than they are asking you, just like a recommendation at the end after you finish all your complex work. Yeah. And that, huh?
After I think it.
Okay, after. And you can think about this, and this project is going to follow you for the rest of your life, that's for sure. You will see why. And that means this is not going to end even when you graduate. You understand?
I know that. But
and you can do it.
I need to really focus because I don't have too much time.
I am focusing, doing that. You will do the same. But remember, many times when you are focusing too much, you cannot see it well. It's because you are focusing too much, stressing too much, you know? So I think you should take a picture of that, and later, everything. You have everything like this.
Basically have the same.
And the chart of this, controllable and state variables.
Yeah, basically.
Okay. Yeah, very cool, very cool.